Okay, so it's 4 o'clock here in Bilbao, and many different times around the world. We have a lot of people joining in this ODOUR talk we organized this year. And first of all, I would like to say thank you to all of you for attending this ODOUR talk. We really took a lot of care, and we put a lot of love in organizing this. It took us really a really long time, but we are finally here with this set of experts that I'm very happy to introduce you today, that are going to speak about a topic that we all are aware of, and that I think they have different opinions, and probably I hope that from this other talk we will be able to get a general idea about the difference between ODOUR and Annoyance, and about the dose, which is the aim here. All right, so my name is Carlos Diaz, and with me is Cynthia Izquierdo, that she's today a bit sick. She was supposed to be doing this, but
sorry for that.
so she's around anyway. Okay, so I'm going to share my screen. We are recording the meeting. Okay, please, Cynthia, tell me if I forget something. We are recording the meeting. We are sending this meeting recorded to the people registered. We still don't know if we are going to be able to publish all videos in YouTube, but for people registered, you will get a recording afterwards. And is there anything else that I'm forgetting?
No, that's all, I think. Just remember to all the people to turn off their cameras and microphones during the presentation, please.
Yes, yes, please. All right, so I'm going to share now my screen. This is the program. So welcome again. I don't know if you realize that there is, you know, that there is this International Commission on Biological Effects of Noise. They have been organizing conference on noise induced effects on human beings for over the last 50 years, but to our knowledge, there hasn't been any other forum of discussion for others. So this is going to be the first one, and I hope it will be the first one of many more to come. So today, I wanted to introduce you to our 5 speakers. Kirsten Zucker will speak about FIDO and a model on the development of ODOUR Annoyance. Hugo van Veloas will speak about percentiles or ODOUR hours. What is to prefer to describe the ODOUR dose? Jean-Michel Guillot will speak about the FIDO's factors with subjective levels to characterize ODOUR exposure and potential annoyance assessment. Susan Schiffman, Kirsten Zucker is, I will introduce each of them afterwards. Susan Schiffman will speak about psychological and biological consequences of exposure to malodors, and Hans Moshammer will speak about ODOUR annoyance science for regulatory action. So our first speaker for today is Kirsten Zucker, who is a psychologist who has been studying the effects of odors and irritants in ambient air, indoor environments, and the workplace since 1998 at the Research Institute for Prevention and Occupational Medicine of the German Social Accident Insurance Institute of the Ruhr University Bochum, IPA. So please, Kirsten. Okay, stop sharing my camera.
So I'm sharing my slides.
Yes, please.
See them? Okay. So as we have not so much time, I will start now. And I'm really happy that so many people registered around the world. So first of all, I would like to show you the exposure response model on the development of odor annoyance. This is the basis of my work for more than 20 years now. And the idea behind that is that symptoms like, for example, headache or nausea are not caused by the odor itself, but the feelings of these symptoms are attributed to the perception of annoyance. So annoyance can be measured on 3 different ways. For example, there are behavioral changes. You can't leave the window open when you're sleeping, or you can't use your garden as you want. The next one are physical or emotional symptoms. Of course, for example, also to be angry, that it always smells every time. And the third one would then be to complain towards the authority or the operators of the company. But to come back to the left side, here you see the odor exposure. You can measure odor exposure at the resident's nose. For example, you use calibrated and trained assessors. In this case, the nose is the sensor. And here you can use these pedal factors. Or otherwise, you can also calculate the odor exposure, and for that, sometimes they also use the vital factors, and I want to show some of my experiences with these 5 factors. So I would like to suppose that computer simulation can do frequency between 0 and 100%. And I would say that in the perception of the residents, they count if there is an odor this day or if there isn't. And the other thing is the intensity. For example, on a scale from 0 to 6, I would say if the odor is detectable. So for the residents, it's another day with odor. They don't count, for example, a 3, so it's distinct, and today it's more intense than it was yesterday or last week. For them, it's only there is the smell again. So, and you have to know that sensitization can be a stress factor, and stress lowers the odor threshold. The next thing is the duration. You can count, for example, the hours of a day and the hours of a week and of a whole year. On the residential side, you have to have in mind that there also are effects like adaptation or habituation, which can increase the odor threshold. Then the fourth is the offensiveness. For example, you can choose the hedonic tone, that is the unpleasant, neutral, or pleasantness of an odor. So I would suppose there are no neutral odors, and I can show you. And the last one is the location, often called the rural or the urban areas. I would suggest better to use all these non-olfactory influence factors, which you can see in this model, and there are a lot of them. So I would always recommend to involve the residents if you're talking about odor exposure assessment or inventing some computer simulation models. The next thing to show you the influence of frequency intensity on odor annoyance. This is from a paper from Poland, and they found out, as you can see here, if there is the odor all the time, 100%, and the intensity is medium, for example, on this scale, a 4, then nearly nobody is annoyed. So what happens? So they are used to this odor. It happens every day. It's not really intense, so it's always there, and nobody is annoyed then. But if you have a low intensity, only 2 on the intensity scale, and it's really seldom, then the annoyance is much higher, nearly 50%. So what happens? So it never smells, and suddenly there is this distinct smell. You can't really know where is that coming from, and you have fear, so something must have happened, and there is then the annoyance. So for the influence of frequency and intensity, it is not 1 and 1 is 2. And this is a good example from New Zealand, where you have the geothermal sources, and this is hydrogen sulfide, so a really bad smell, and it's always there. And you can see that nobody is complaining. So what happened? It is always there. And you might guess that the people are that habituated that they can't smell it anymore. So there was a study, and they assessed the odor threshold for hydrogen sulfide. And guess what happens? You have this low sensitivity area where you can smell this odor. So here you can see that the odor threshold was much higher, 1.1 microgram per cubic meter. And in the areas more far away, the odor threshold was much lower. So is it really true that those people who live in an area where you have the smell every day have a higher odor threshold? So it's physiological? No, it isn't. So what happened? When the people came to the house where the study took place, then if they had a day with more odor than usual, then they came to the house and they were or habituated already. And this is a temporary desensitization effect. So this was about a factor of 10. And then they made the measurements. And then, of course, the olfactory threshold was higher. But normally, everyone in that area can smell in the same way. So another suggestion is that there are no neutral, as we call it, odors. So we had a study with 6 different odors. 2 were pleasant, 2 were unpleasant, and 2 were, as we call it, neutral. So we had the assessors standing in the area around the companies and smelling. And they had the the hedonic tone scale with -4, extremely unpleasant, neutral in between, and then a +4, extremely pleasant. And we also asked the residents living there. And you see here that the residents' statements are always lower or more unpleasant than that of the assessors. And the really neutral odors didn't exist in the face of the residents. So our neutral odors were -2 or -3 then. So I think residents don't compare odors like we do or like the authority do. So in the case of agricultural odor, they don't tell you, oh, cattle is less annoying than pig odor if they only live in an area where you can smell the pig odors. They can't compare. And
2 minutes.
what you see here is that you have a distinction between pleasant and not pleasant odors. So I would say involve the residents if you want to find out more about the odor annoyance and use information on olfactory factors. This is all from my side.
Sorry, Kirsten, I just meant that you had 2 minutes. You still have 1 minute and a half. If you want to say something else, or okay.
I know.
Okay. All right. The next, thank you very much. Questions will be made after all the 5 talks, if it is okay for all of you. All right, so we go with our next speaker, which will be Hugo van Veloos. Hugo is an environmental engineer from the Wageningen University who has worked in the Netherlands other nuisance field for over 30 years. He has operated both in the consultancy and with the government. In addition, for 5 years he has worked as an independent consultant in the field of air quality and healthy living environment. So please, Hugo, you have 10 minutes. Turn on your microphone. Can you do that? Or...
Yes. Now
Okay.
I'm there. But now the screen. Here we have the screen. Yes. Okay. I hope all of you can see it in a proper way. My talk is about the percentiles or odor hours. I'm from the Netherlands. In the Netherlands, we use the percentiles all years. We have odor policies and odor in practice with licensing or spatial planning procedures. I'll try my purpose is to make it some more practical, in a practical way, joining the talk with Kirsten, because we think the same, but act probably for you to decide or to judge if we work the same way. This is what I want to talk about, how to describe the odor dose. When does some odor exposure change into annoyance, and to so much annoyance that people complain? I think, well, for every one of you, I think this is a very clear picture, and you recognize it all, I hope. It says in every odor situation there is always very changing pattern of odor concentrations. Some days there is no odor at all. In other days you have the odor present from early in the morning till the evening, or everything in between. The concentrations also differ from day to day, from hour to hour, even from minute to minute. That's the fact we have to describe, because people react on this type of pattern. This is the odor dose they get, but how to describe it? As I say it, or see it, or talk about it today, you can express the odor dose in two ways. By counting in hours, how many hours is the odor present? Is there any odor present? Like Kirsten Zucker said, for the people, that is what really matters. It smells again, or words of the same meaning. Counting hours or ranking concentrations. That is what we use in the Netherlands. It's our standard way. We rank the concentrations and look at the percentile values. Which concentration is at a certain percentage of time. counting or ranking. The discussions I already had well with for instance Kirsten Zucker from Germany shows this interesting fact, I think, that those response curves existing all over the world can be based on both the ranked dose of odor or the counted dose of odor. Dus it can be the same dose response curves. It looks very, very similar if you express it as a P98 or you express it as a number of odor hours or an odor frequency. Okay. Counting or ranking compared. That's my main purpose for today, to give you this and see what everyone's experience or is on this topic. For me, like we try to describe it with our dispersion modeling or with measurements in the field, both ways are possible, is an expression of two elements of Vidal factors, the frequency and the intensity, where it's, for me, I think it's very important to recognize that a P98 is an intensity level at a fixed frequency, and the odor hours is a frequency level at a fixed intensity. A fixed intensity, the number of odor hours at a fixed intensity. That's the intriguing part, I think, for not only for me but for many more, I think. And to come with my conclusion or my talk of today is let's give you the best way to describe the odor dose or the exposure which is leading to any level of annoyance with the people. I think the best way is counting. I'm talking to you as an expert in the Netherlands. I say it here, but it's not the common way of thinking in the Netherlands. Let's be clear on that. But counting the odor hours is the very important thing to do, I think. And maybe you recognize it, or maybe we can discuss about it later. Why is counting the odor hours so important? Because it's based on the level of odor detection in the field. So for what hours recognize the people in the surroundings near a source. So the odor is present again, like Kirsten Zucker said, they recognize the odor is present or not present. And that's what you reach or realize when you count the odor hours. But it's very important also to be aware of the fact that hours have different levels of intensity, and that you have to count in such a way that you take into account the different levels of intensity. Or as we in the Netherlands, because we use the percentile values the most, that's our standard way of calculating or judging on odor situation. In the Netherlands, we say, you have to look at all percentile values. not only the P98, the 98 percentile. No, that's for sure not the right way. And why? Well,
2 minutes, Hugo.
Yes, very good. And why? I'll try to make it clear to you in just one slide or maybe two. There are two elements in this. The one, well, Kirsten Suker showed it already, I think, but here it is put in another way. You have an hour, 1 hour of odor present is not the same because as another hour because of differences in the intensity. And if you look at the here the odor concentration in a short notice. So what do people smell? Only 2 minutes, only 2 seconds, whatever. There's those concentrations give an odor, an 1 hour odor value and a certain percentage of annoyance. So an odor hour with, let's say 5, an odor hour with 5 odor units gives 60% of the people being annoyed. And the second element is the odor dose is not 1 percentile or represented by 1 percentile. No. It's all hours with odors recognized as odor present. So all odor hours. And you have to be aware of the fact that here you have the P98 percentile and here the 99.9, so 10 hours a year, that there can be differences and it's caused by very, very many factors. So different situations, different sum of hours of different odor levels. Which brings me to my conclusions for today. The end. My 10 minutes are over. What? 11 minutes are already there. This is what I mean, meant to say and to put on screen for you for the discussion. Thank you.
Thank you very much, Hugo. So the small bucket with a high intensity and big bucket with a low intensity, right?
Right. Yes.
Very good. Very good. Okay. Thank you very much. And we move on to our next speaker, who is Jean-Michel Guillot. I'm never pronouncing your surname right, Jean-Michel. I'm sorry.
No, it's okay. It's okay. Thank you, Carlos.
Okay. He's professor at the IMT Mines-Salève in France. He has published over 150 papers in international journals, conference proceedings, and book chapters. And he has been involved in almost any initiative related to managing odors in Europe. As an example, he represents France and AFNOR at the same level for elaboration of standards about odor measurement. Okay, please, Jean-Michel.
Okay, thank you, Carlos, for organizing this session. Can you see my slide? Okay.
Not yet.
Not yet. Okay. Just to okay. Maybe now.
Not yet.
Not yet. I have to try something else. Sorry. Okay. So I will use the PDF. Now it's okay or not?
No, you have to go to the sharing screen because you're not
Yes,
sharing
yes.
your. If
Okay.
if you want, we can share our screen because we don't.
Sorry for that. Okay, it doesn't work because.
I can share my screen, yeah, Michelle.
Okay. Now I think it would be okay.
Yes, now it's okay.
It's okay.
We don't see in the present. Now it's okay. Now you have to switch your screen because we see one big screen and a small one. You have to switch the screen. You know what I mean?
Yeah. Is it okay now or not?
No. Yes, now it's okay. Now it's okay. Yes.
Okay. So, sorry. Okay. So, in order to complete the presentation of Kirsten and Hugo, I will discuss about FIDO or FIDOS factors, and we'll explain the difference with another point of view, and mainly based on subjective approach, because typically sometimes we have objective measurement, and Hugo insisted a lot about the counting, but when it's just a feeling, it's sometimes difficult to count. So first of all, when you are exposed to an odor, you can ask, in fact, a global feeling for population. So all the proposal is to use the factors with 5 level, and even for the global answer. So it's quite easy to characterize the impact from a small one to a big one. And of course, the question could be, what is the beginning of an audience? Is it at level 4 or at level 5, depending on different things? The objective is really to detail and to understand a little bit more how you can consider this global impact. So for that, of course, we can use FIDO factors because it's quite a useful tool to describe complaints and potentially annoyance. But sometimes we mix subjective data with objective data. And because odor perception is typically subjective, I think we must have an approach typically based on subjective responses. Why do we propose FIDOS? Because in fact, the last one, location, consider a lot of things, and maybe we must more consider the human receptor. So sometimes it's FIDO, and more the sensitivity of this human receptor. So that's why we can call that FIDOS. And Carlos, you know that FIDOS for you is more important than FIDO. But I will explain that. Just to come back with all these factors, okay, we all agree that frequency is between never to all the time. Okay, we can count, and you go say that, of course, we have the percentile 98% that exists in many countries. But can we really consider for people that if you are less than 2%, they are not exposed? I just give you this example. You are a neighbor of a chemical plant and you have a process with a big event with a very bad odor twice a day at 6 a.m. before you go to work, at 7 p.m. just when you come back. And of course, if this odor peak is just with a duration of 12 minutes, it means that in fact it's 1.7% of the time. So theoretically, less than 2%. So theoretically, without any problem, so you respect this the percentile 98%. But if you ask to the population if they are exposed in terms of frequency, you will probably have an answer like often or very often, because it's all the day, twice a day, and of course without break or that. So we can see that an objective measurement, for example, like with a sensor and the perception, can be really different. For intensity, okay, we also propose to have 5 levels because for pain, for example, we can have 10, but between level 2 and 3 or between 7 and 8, not so different. So I think you have just 5 levels, very weak, medium, strong, and very strong is enough to characterize an intensity. For the duration, it's a little bit like for frequency, what do you consider as a long? Of course, you can have a measurement, always with a sensor, but for some people, you can say that a long episode of odor is just 10 minutes. For another people, it's 2 hours. So always in that case, the perception can be very different. Probably the more complex in all these factors is offensiveness, because of course, you all know that sometimes you have a numerical level, typically in some VDI guidelines from -4 to +4. But in fact, for even a pure compound, and typically if we take the example of limonene, the perception of this odor can be very different depending on the concentration of this compound. So you just have to describe the offensiveness, of course, for one situation at one moment, because of course, depending on the time, with more dilution, sometimes your perception can be very different. So that's very complex. And of course, in that case, we can also propose 5 levels to describe. Kirsten says that neutral doesn't really exist, but I think we must put something that is more or less between the transition of present and unpleasant. In fact, globally, unpleasant and very unpleasant, you started to be annoyed, and neutral, you are just exposed to odor, even if it's not pleasant for you. I think we can consider in that way. And for the last factor that we can use that sensitivity, of course, location is important, because if you are at home, at workplace, your perception can be different. But why do we have to consider the sensitivity? Of course, if you are tired, if you are ill, if you are very busy, if you are stressed, your perception can be different. If it's a weekend or not, and maybe also on your mind, the weather condition can have an impact on your feeling. So the objective, we don't have to add fiddle plus weather plus well-being and so on. So we can regroup everything with the 5th factor in terms of sensitivity. And also for that, 5 levels to, okay, are you very sensitive at this moment and at this location or not? So the objective with 5 levels, 5 factors, you can ask to population really their subjective feeling for all these factors. And of course, you can have some answers. And one objective is, of course, for one situation, is to try to find a way to integrate the answers for the 5 factors with the global one. With this example, you can see that, okay, the receiver, it's more or less at level 4. So we can consider that intensity and offensiveness could be enough to describe the situation. So the idea is typically, of course, to see if with different situations and in different countries and different industries, we can find some relationship. And of course, to more estimate differences about subjectivity to see if finally FIDOL or FIDOS factors are enough to understand the situation. Eventually to propose a limit between exposure and annoyance. And also, of course, with all these factors, the objective is clearly to illustrate the interaction. And Hugo clearly mentioned that between intensity and frequency, we have a strong interaction, of course, but also with duration, with other hours. So do we have with different situations the same weight of each factors? Do we have the same interactions? And of course, if we can define a critical level to characterize annoyance. So that's globally in this concept. We just start a research program on this subject. And of course, we'll be happy to collaborate with some of you if you want to propose some data in some to carry out some questionnaire in some situations. Okay, thank you.
Thank you very much, Jean-Michel. You could hide this bar you see in the bottom. I forgot to tell you.
Sorry?
Yes, you can stop sharing. Yes, okay.
Yes, of course, yeah, okay.
All right, thank you very much, Jean-Michel. So our next speaker is Susan Schiffman. She is a well-known expert with over 300 publications, some of them on ODOUR and health issues, at the Department of Biomedical Engineering at the University of North Carolina, North Carolina State University. Her other work is focused on landfills and hog farms. She is also chair of the IEEE working group developing standards for electronic nose technologies. Oh, Susan, are you around? Yes, you are.
Yes. Okay. My major problem is now, how do I share? Okay. I think I need something from you to share the screen.
Just try at the top of the share screen button. If not, I can share the screen. That is not a problem.
Let me see. I may. Do you see a share screen button here?
Yeah.
Where should I? Okay. Where?
You touch the camera, then the microphone, and then the screen.
Settings.
Yeah.
There's
no
share screen.
Top middle. In the top middle, you have the camera, the microphone.
Okay, got it. Okay. All right.
Okay, we see your screen.
All right,
yes?
got it. Okay, I'm going to describe two studies that we did on exposure to hog farm, that describes something on exposure to hog farm malodor. Animals throughout the world are frequently raised in barns that are ventilated by fans. Those circles at the back are fans. These are called CAFOs, concentrated animal feeding operations. And the ventilation fans are used to remove the odorants and the dust, bacteria, and fungal spores from the houses. And of course, all of that goes into the atmosphere. In North Carolina, we have many of these farms that are concentrated in several counties. And there'll be many of these houses on the property. And the odorants go out from the fans, but also fecal material and the fluids go into these large lagoons, the water areas here. And then that water is then sprayed onto the fields for irrigation. So there are three areas, three sources of odor, which is the houses, then the lagoons, and the spraying. I'm going to give you two studies that we did. The first one's very simple. People who live downwind from these facilities complain all the time. And first study we did was simply use the profile of mood states. This is a standardized test. It's been translated into 42 languages. It has 65 scales on it that tell different types of feelings. And basically they fall into 6 categories, which I'll show you on the next slide. So we had 44 experimental subjects that lived near these facilities, and they were simply asked, just fill out one of these profile of mood states questionnaires on 4 days when you could smell the odor. And then we had 44 control subjects in similar rural areas, but without the swine facilities. And these scales are basically tension, anxiety, a depression scale, an anger scale, a vigor scale, which is the only positive one, and then a fatigue score and a confusion score. So when we analyzed the data, we found a surprisingly large mood disturbance. It surprised me. The hog farm neighbors had more tension, more depression, more anger, less vigor, more fatigue, more confusion, and then when you sum all this up, the total mood disturbance compared to the control subjects was huge. So I told everybody I would debrief them, and when I talked to these people, they all complained of physical symptoms, which is the thing that just, so that was the impetus for the next experiment. We have a swine facility at North Carolina State, and this is one of the houses. And I decided I asked permission to take this little house here that was for tools and to convert it into an environmental exposure chamber, which I got permission to do it. And I pulled the air out of this swine facility into this little exposure chamber, which I will describe to you now, and then I'll tell you the experiment. What we did is we got a filter to completely filter the air because it's obviously very smelly there. I got this from Canada, from a company called ODOUR, and they helped me with a HEPA filter and some specially formulated cartridges to clean the air. It was really cleaned. And then we mixed that filtered air with the swine air from the fans. We pulled it through, we set up this system where we had this air distribution duct, and there were holes in it, and that's the distribution. This is the ceiling. And the surface materials could be easily cleaned. And then we vented that out, the exhaust, through table legs, because we set some tables up in there, made out of PVC pipes. So we put tables in there with dividers, and you will see some of these instruments in a minute to measure what people were exposed to. We used a photoionization detector from a PPB ray for the VOCs. Hydrogen sulfide was with a gold film sensor, which from Jerome. And then the particulates we did with gravimetric sampling. We also used TEI model 17C for chemiluminescence for the ammonia. Also, for the endotoxin, we collected it on fiberglass filters using a piston pump. So the air samples, we also took air samples in canisters and 10X and carbon traps, doing GCMS to find out what compounds were there, and also GCFID to look at the total carbon. We also measured odor thresholds with the portable olfactometers, and we did some laboratory work as well. Here's the nasal ranger, which from St. Croix, an old scentometer, which has been used for many years. But we also did the Tedlar bags and brought them back to our lab to measure the olfactory thresholds. So here's the experiment. We took 48 adults, aged 19 to 49 years, half women and half men. Our institutional review board made sure that I had to screen them all for no asthma, no allergies, no smoking, no medications, no heart or lung disease, no occupational exposures, and definitely not pregnant. So in the experimental session, they were exposed to air at levels you would expect about 750,000 feet down from a large swine operation. In the control session, they were exposed to clean filtered air, and those were randomized across subjects. We picked everybody up. They had to be wearing these masks. This is a 3M Model 6000 series. It filters out the VOCs and the particulates because they thought they didn't know they were doing anything to do with odor. They just thought they were being exposed to a swine facility. Here was our exposure level. We spent a lot of time getting this down pat. The hydrogen sulfide was at 24 ppb. The ammonia was at 817 ppb. That's below the odor and irritation threshold for ammonia, but above for hydrogen sulfide. These are the particulates and the endotoxin. The odor levels, we got pretty much at 56, 57 dilutions to threshold. And we measured the total VOCs with the GCFID. Now, these are the assessments. First, we wanted to look at immune status. So I dropped fluids into the nasal cavity, and then we took the samples looking at polymorphonuclear leukocytes and the pro-inflammatory cytokines. We also collected saliva for IgA, which is related to stress. We did spirometry. There were some assessments on scales. We used the US EPA EEHQ, which is people relate their symptoms on that. We did the mood scales again, the POMS. We did attention and memory tests and odor assessments and vital signs as well. During this, we had to have a physician present and 2 nurses. The measurements were done at baseline. While they were in the chamber at 30 minutes, we did the mood, attention, and memory and the odor ratings. And then at the end, we did everything except the nasal lavage, which we did later, and some more measurements as well. Well, what did we find? We found highly significant increases in headaches, nausea, and eye irritation. The exposed group also had an increase in the absolute percentage of lymphocytes in the nasal cavity. The exposed group rated the odor as moderate strong to strong, with adjectives like fecal, sewer odor, musty, earthy, moldy, urine, and sweaty. The control group barely detected anything and had no adjectives to report. There was a trend towards slight impairment of mood, but not statistically significant, and no other changes. So basically, what we found with regard to the headaches, eye irritation, and nausea, that in the exposure condition, people were 4.1 times more likely to report headaches. Look at the p-value. Eye irritation, 6.1 times more likely. And nausea, 7.8 times more likely to expect in the exposure conditions. So our conclusion about these 2 particular studies is simply that experiment 1 for people in communities that swine odor can impair mood in these downwind, and in an exposure with people that are very, very healthy, that exposure can cause headaches, nausea, and eye irritation, as well as affect the lymphocytes after 1 hour of exposure. So that's all I have to say right now.
Thank you very much, Susan. Very interesting presentation. How long did it take? Okay, so question afterwards, sorry. Okay. All right. We go to our next speaker, who is Hans Moshammer. He studied medicine and worked for public health services before joining the university and environmental health science in 2000. Because of his prior experiences and current research, he is interested in the impact of all environmental stressors on health and well-being, including odors. In addition, from his work in administration, he is aware of the need to define limit values and set standards. All right, Hans, here go.
Yes, but Susan was still...
Oh, you can take her screen. You can share. You can take a...
Yeah, I still have the share screen up.
Oh, yes,
okay.
but...
it works. Yes, thank you. Can you see my screen now? You should see my presentation. Fine. Thank you. Yeah, I'm really glad to be in this meeting. It was wonderful until now. I have not much to add. I also want to talk about FIDO and then about guideline values. Most has already been said, but maybe I have a little different approach to it. Frequency, intensity, duration, offensiveness, and location. Offensiveness, of course, is an important issue. because no two odors are the same. The location determines our expectations, and other typical odors of the locality can mask the offensive odors and influence our perception. But why do we use 3 different measures of exposure? Are we fit for FID? Yes, this is true for a rather continuous production of odors. In an example like this chemical plant from the previous colleague, where you have an exposure only twice a day and in a very incontinuous production of the odors, this might not be true. But when odors are produced more or less continuously, the concentration frequency curve is always something like that. And so you have a certain average concentration, you have a certain concentration at an arbitrary percentile, or you have a frequency or a percentage above this percentile or a concentration, as we talked about. So all these values, concentration, intensity, and duration, are somehow correlated with each other. As we also found in our own data, where my colleague ran this dispersion modeling, and he calculated the percentage of hours with odors compared to the odor unities at the 98th percentile. There is a strong correlation. It's of course not perfect, but also the results of this dispersion modeling, also of field inspections, are not perfect. So I think given the measurement error we have, it doesn't really matter which metric of exposure we use. In Austria, of course, and in Germany, in the German-speaking countries, we usually or traditionally use the frequency, the percentage of hours above the odor threshold. This is traditionally so because that's the measure that also stakeholders, neighbors, and also the owners of the enterprise can measure and can agree on, while concentration is very difficult to assess without technical devices. Odor hours have been developed in standards, so it's clear how to measure it, how to calculate it. Of course, there's still differences in the dispersion modeling and many problems in detail, but in general, these odor hours do work and are fairly equivalent to other measures of exposure, as long as the odor source works more or less continuously. So we were faced with the question how to rate the effects of odor on health and annoyance. Looking at health and annoyance might be an Austrian specialty or curiosity. I don't know about the legal situation in other countries. And according to the World Health Organization, like, for example, expressed in their noise guidelines, there is no difference between annoyance and health. Health is also social and psychological well-being, so also annoyance is means poor health. For example, in the noise guidelines, they define more than 10% highly annoyed as an adverse health effect. In Austria, we have adverse health effects, and that by law must be prevented at all costs. Even a neighbor who comes later has a right to request that health-endangering exposure can be removed. While annoyance is only to be prohibited if it is not acceptable. And what's acceptable also depends on the costs of the prevention and on the location. And a new neighbor has no right So there is a difference between annoyance and health effects. Although, as a medical expert, I see no clear distinction between annoyance and health, because long and intense annoyance is certainly a pathway to cause stress and to cause neurovegetative and therefore irreversible biological damage as well. Right. We have very clear rules for noise, but not so clear rules for odor. But these two stressors act in a very similar way. The intensity for noise is decibel, while intensity of odors is measured by odor units. The offensiveness in noise is measured through frequency distribution, to the peaks and other typical events of a noise event, while the offensiveness in odor is just different chemicals have different odors. The health effects are a little bit different because the acoustic signal is also linked to the formatio reticularis, so not only causes annoyance, but also arousal and can cause sleep disturbance. The olfactorious directly goes to the limbic system, which is closely linked to memory and to emotions. So of course it also causes annoyance, but maybe not this sleep disturbance, which is an additional factor in noise. But the close link to emotions and memories, of course, also a problem to be considered. In noise, we have relatively clear curves also provided by WHO. The blue curve is the percentage highly annoyed, depending on the day-evening night weighted exposure levels. And the red line is the percent increase, so the additional risk of incidence of ischemic heart disease. And what I showed here is the errors, is the limit values proposed for road traffic noise in Austrian law. We have unacceptable annoyance, depending on the location, somewhere between 55 and 60 decibel, and adverse health effect defined at 65%, where according to WHO we have already really a significant increase in cardiovascular disease. This would translate to more than 10% or 10 to 15% highly annoyed as being non-acceptable annoyance. And when annoyance reaches more than 20%, maybe 25%, you have so much annoyance that these psychophysiological mechanisms will lead to stress that will lead on the long run to cardiovascular problems, hypertension, ischemic heart disease, and so on. So if we use these percentages of highly annoyed to also set limits for the odors, we can proceed. And just another picture from the noise guidelines. It's not only for odors, it's also for noise that, depending on the study and the location and the setting, and maybe the very questions asked, you have a huge variability in the outcome. So these effect estimates are, of course, only an approximation of the truth. And the same is true for odors as well. We do have very clear dose response curves for pigs or for chickens. And when we use the percentage of highly annoyed allowed for noise exposure, we can end up with 45% odor hours or 50% odor hours for pigs or for chicken, respectively, as absolute limit value, which is not allowed, where even when you have the stable here, you're not allowed to build a new house for living when these concentrations are exceeded. While with 15% and 10% odor hours, you have an unacceptable odor. So as long as it is possible, whenever you have you plan to change, you have a new project, you should try to get below these thresholds.
One minute.
These dose response curves are based on a study by Zucker et al. But when we used the Dutch study with the intensity instead of the frequency and recalculated it was equivalent. And also our own data, where we didn't look at ideanoid but at complaints, really fitted this data. So I think it makes sense to use this study for pigs and for chickens. But we do not have good annoyance data for many other odor types. So how do we proceed? I mean, we could use expert ratings of the offensiveness. We could do more field studies. We might even do studies in the lab. Or it would be good if we had more objective measures. But as we saw in the last presentation, there are not so many easy to do objective measures like respiratory rate, heart rate variability, lung function, that really inform about health effects of odor. So there's still lots to do, but I think at least for the major odor sources, we have a good idea how to limit it in guidelines. Thank you.
Okay, thank you very much, Hans, for your. You did it. Thank you very much. All right, so now we have 10 minutes for questions, more or less, and then after that we will have a round table, and I will ask you to open your camera. But now what I would like is to ask to the speakers to turn on your cameras, please. Jean-Michel, Susan, Hans, Hugo, Kirsten. And for those that would like to make a question, here you have the chat, please. Put your name there so that we can go orderly with the questions, and so we have 10 minutes until yeah, more or less 15 minutes past 5 here. There, wherever you are, is 10 minutes more. All right, questions?
Seems we have confused them.
I think it was wonderful to listen to the 5 of you, and I really enjoyed the different points of view. I was surprised by some of the talks, but I think you all agree that maybe there is a need for more studies on influence on health of the odor impact, right? So questions?
Not really a question, just a comment. Of course, we all know that an health effect, you have the direct one with the mixture of compounds that can have a physiological effect. Of course, the annoyance can have an effect more on psychology. But what was very impressive is that the immune response in just 1 hour with nasal sampling in the study with Susan. And so typically a physiological effect, and it's quite strong and very fast, just 1 hour of exposure. And so it's quite new, this kind of data.
Yeah, what happens is that over time, something may not be an irritant at the beginning, but it starts building up over a period of time. There's a guy by the name of Ken Hudnall at the EPA in the United States who did a study on indoor air, and he put people in a chamber, very sophisticated chamber that the EPA has, And at the beginning, the odor was strong, but there was very little irritation. But over a period of time, I think he did 75 minutes, the irritation went way up, and the odor intensity, of course, went down because of adaptation. And I think that's what happened to us as well, is that I only measured odor at one time because of all the other tests we were doing. But what happens is that over a period of time, that irritation builds up. And that's what the problem is. And people who can tolerate it are people who don't have strong responses to the trigeminal nerve. And you can adapt to that. You can get adaptation or you can get sensitization. And I think what happened here is we get the sensitization.
Okay.
I was surprised, to be frank with you, that the people who sponsored this, I had two major sponsors. One was an environmental group and the other was the Pork Council. So a lot of my money to build was a very expensive project, let me tell you, just from the standpoint of materials and time. But the Pork Council was one of the major sponsors because they didn't think anything was going to happen, and neither did I. I wasn't sure. I had no idea.
Mm-hmm.
So what you describe is what we do in our exposure lab. We do studies on single substances and measure odor and irritation effects and try to find that concentration where you have at least no effects, and we use our data to find the limit values for the workplace.
But that's a single substance, and I think the problem is that you can take, and I've done this, you take 10 compounds that are all below the odor threshold, and you put them together, you can get a strong odor and a strong irritation. So that the problem for limit odors, at least from my point of view, is that that's really not a way to go because you have to have the mixtures.
Yeah,
and
I think that's true.
It just costs a lot of money. That's the problem.
Yeah. But you have to think about also that we talk about odors in ambient air where the residents live, and there are some distances between the houses and the companies, and also you have some kind of dispersion. So I think it will happen really, really seldom that you have that high frequencies and intensities we are talking about. So what we found outside was in our agricultural study, the most intense odors were a 4 on the scale up to a 6.
Right. I mean, an experimental study works on healthy people in a short period of time in a small group, so it needs higher exposures to get a significant effect. In the environment, you have lots of people, also vulnerable people, exposed for many years, so even lower concentrations might matter. But yes, it's difficult to translate from the lab into the ambient situation. But I want to agree that, of course, the mixture always matters, and this is the difficulty. I mean, you can use the mixture from a hog farm, but that's just one type of exposure. What do we say about the chicken farm, the cattle farm, and the industry, and the bakery, and the brewery, and all have other different mixtures and different smells. I hope that smell is relevant. I mean, we like some smells and we dislike some smells. This has some biological function, or else we wouldn't have developed likes or dislikes. Of course, there's individual experience and cultural influences, but overall, that's our perception of an odor is based on its dangerous or beneficial properties of the substance. So I think of course, it's a psychological effect, but also it's a signal for underlying dangers, toxic dangers, irritative dangers, or even infectious dangers when we look at animal emissions. that it comes with the odor, and we should really take it serious.
I see we have a question in the chat.
Yes, it is in Spanish. I will try to translate it. It's from Eric Concepcion. I think he's from Peru. And he makes a question about that there is a fishing industry, and he asks how can we measure how the odor management is made if the population is already adapted to this offensive odor of fish or fishing. How can we measure that if they are already adapted to that odor?
So why should we? If everybody is adapted, so there is the fishing industry, and of course there is odor, but nobody has a problem. Nobody is annoyed, so why should we measure? So, but imagine if something if a person is moving into this area, maybe it's the first, which has really a problem then. So then this person has a really big problem if nobody else is annoyed. But this could change, of course. Huh?
Yeah. All right, it's 15 minutes past 5, so I give the lead to Kirsten, who is here. Please, I encourage you to turn on your camera, so please turn on your camera. The rest of the people here, if you want to make any question, please put your name here in the chat, and maybe Kirsten can deal with all the list. I have to leave now, so thank you very much, Kirsten. It's your go.
I would like to come back to the second question, which was from Katrin Kwiatkowski. So her question was, if the reactions are caused by the odor impression or by the chemical molecules that cause an irritation. I think it's a question to you, Susan.
I think it's caused by the sensory activation of the nerves. And in one of the first slide from Dr. Zucker, she had substance P and nitric oxide on one of her slides. What happens is when the trigeminal nerve is stimulated, then there's a whole series of cascade of events that happen in the nose. But it is the stimulation of the nerve, and then there's the subsequent effects. It's called neuroinflammation that occurs, but it occurs because the nerve is stimulated. It's the sensation that causes the inflammation. It's different from a compound actually damaging the tissue. So there's a whole system it's a very complicated chemistry that's involved, but it's very clear now as to what's released and how the blood vessels are dilated, and then there's a whole sensitization that occurs as well. So this is well worked out, but it is the nerve, the odor, and the compound itself and the effect on the nerves that causes the effects. At a higher concentration, of course, then you get toxicity.
So, Eric, have we answered your question sufficiently?
Carlos, I understand my question. Thank you very much.
So, the next question. If you don't want to write, you can also just talk.
I just realized there is a button to raise your hand in case someone wants to use it.
But there are so many people and so few on my monitor. Maybe I can't see the raised hand. So I think I would suggest just ask your question. So this ODOUR talk is living out of your fine questions.
Anyone can just switch on their microphones. It's on the top of the platform, and you can ask your question.
I have a question. Okay, I'm gonna turn on my camera. If there was to be any research on this topic, what would you think would be the best approach at this stage? If there was to be any research, some of you said that please do more odors, not only pigs and composting plants. Some others said that please study other health effects. What do you think would be the next steps if we wanted to study those effects, and if we wanted to get, for example, research money for that? What do you think it would be the best first steps?
Well, I think it has to do with quantifying the exposure, and we're working with that at with IEEE right now, looking at electronic nose technology, and I think that's a major direction that we have to go. We have to be able to quantify odor. As Dr. Moshammer said, odor is important. It's not necessarily the individual components. We need to look at what the pattern is, and then to correlate that with health effects and with psychological effects. And the problem with eNose technology is that there are issues with it with regard to drift, humidity sensitivity, and so we're trying to get some standards to standardize that so that we can relate to the health effects and to the psychological effects. I think those three, a good study using all three of those together would be terrific.
Right. I wanted to add that generally odors are very, very understudied in comparison to other environmental stressors. And of course, the most frequent odors are the most important ones and should be studied more detailed. From a scientific point of view, it would also be interesting to study other types of odors to see what principles hold in general and what are specific to a certain mixture. But for epidemiological studies, you often just don't have enough neighbors or participants for your study if you look at rare odor sources. So you only can do field studies for composting facilities and animal feeding enterprises. So, I think we should also consider more laboratory studies like the ones Susan described. Well, understanding that from the lab to the real world, there is still a huge leap, a huge gap, but it's for understanding the mechanisms, and it is still very important.
So I would always recommend, first of all, to look at all the literature that has done. So there are only a few, but I think more than 10, 15 dose response studies on odor and annoyance. And from that, you can learn how to measure or qualify odor exposure, odor impact, and how to measure the response, if it is important also to measure again health effects, and then in which way. Maybe you should then try to get some new methods also to measure objective features. But we have new questions now. So there is one from Maria Inez. So she is asking that nowadays a lot of things are stimulating the immune system, and all the environmental factors around us. And if there are any study that can compare the stimulation that comes from the industry and other influence factors that coming, for example, from crowded city. Do you know any study that, epidemiological study that had this issue? So I haven't heard from a study that has this holistic view. So what you always find is health effects from noise, or health effects from odors, or health effects from sulfur compounds, or health effects from particles. So they are all have one or a few substances in mind, but nobody looked at it altogether. This is the new approach. Yes.
Right. Of course, in epidemiology, we want to tease apart all the different factors, and the combination of factors is always much more complicated. But I think there's the next question by Elias, who asks if there's a relationship between the chemicals and the particles and the other units. Of course, luckily, if they have the same source, they are correlated. So you can use either VOCs or just a perceived odor, or you can measure particles or whatever. And all these measures are proxy of the total exposure for a given source. So we always, even if we only use one parameter, we're always looking at a complex mixture indeed. Yeah, thank you.
I would say thank you very much for your speeches. They gave a good overview about, and the actual overview. I saw there is a development to look at more than only one parameter, to look at to find a way how to get the whole order situation. I think that's a good development. And I think Susan showed clearly there are health effects. I agree with Susan. We don't have to look at individual components. We have to look at individual sources, order sources, but the components won't give us further ways ahead because we have to deal with mixtures. The other thing is how to come to avoid order exposure and how to qualify situations with assessment, which situations can we tolerate if we look at location or sensitivity at a certain location, and which can't be tolerated.
So we have a hint here in the chat from Rosa on a study on odor pollution and its relationship with chemical compounds and health issues. It's a review. I think it's really interesting, and I will have a look at it, because often in these studies you have mixed up these both exposures. On the one hand, the odor itself, and on the other hand, the chemical compound that has different and multiple effects. So I think to differentiate between these two is really important for every study. And we have so many, I can't follow. We have Ben Hugo. Yeah. And he also thinks that the e-noses are a good idea for the future research, or a combination with the grid odor field measurements.
Another possibility, I actually designed one time, but it was too expensive, would be a traveling exposure chamber. And I think, like Dr. Mosshammer was saying, how do you compare a chicken farm with a hog farm? You know, how could you do this? Well, if you had the same equipment with the same testing, let's say you did nasal lavages to look at cytokines and lymphocytes, and you did salivary IgA, which would address some of the issues of immunology. And maybe the EU would be willing to sponsor such a. I mean, you have wonderful people here, Dr. Mosshammer, Dr. Zucker. If you all went together on a project where you had a traveling exposure chamber where you could test various kinds of physiological parameters, I think that would be really great. Yeah. And then you could compare.
But you have the worst exposure possibility. Because if you directly study the effects in the residence, so you have the most high exposure that is possible, but no residents have these exposure. So otherwise I would go directly to the residents and measure, for example, cortisol or immune parameters.
Well, I think the thing is that you could get a direct exposure, like what I did was to pull the air out of a swine facility. Well, if you had this traveling exposure chamber, you could pull it directly out of a plant, or you could pull it directly out of a chicken farm, and that way you would quantify it, and you would be able to determine, your total VOCs, the components that are there, and then you could compare directly. So you have a direct exposure, and you can quantify what it is, because downwind, I mean, I've tried this. That's why we're trying to do the electronic nose work, but to quantify compounds and to look at exposure downwind is just really tough. But this way, you could do it directly from a facility. Let's say you have a fertilizer plant, and then you would just be able to dilute the air from that fertilizer plant as it would occur downwind and do all of your physiological measurements.
Yeah, but
and it
then
would just
again,
be traveling.
Again, you have the problem to characterize the exact exposure. And what you had was a mixture of the odors, of the sensory irritants, and of particles and endotoxin. So what does, in the end, the health effect, or at what cutoff value? So you have a mixture of that, and afterwards, how to use these results for regulation, for example.
Yeah, I'm not an authority on regulation, so I'm into measuring. measuring
yeah. So
quantification.
This is the last question always then. So we have a question from Philip following Elias. If we know studies that have tried to characterize VOCs, odorants, adsorbed on particles, or particles are vectors of odors, and studies have been done for livestock, and what about industries? So first of all, I have to say it again that there are different exposures. So we have the odor itself. It's a sense. It's like to hear, yes? And then the other things are the VOCs. These are the chemicals. Chemicals can have toxic effects, and then they can have sensory irritating effects on the other senses than the nose itself. So it's the trigeminus. It's another nerve system. And then you have the particles. This is a third exposure. So it's different from the other two. We have done some particle studies in our exposure lab, for example, on zinc. So zinc does fever. The result of zinc is fever. So it's another mechanism in your body. So you have to differentiate between all these. And all these different exposures in one study you can't find. Other answers on this question?
In fact, just a comment about that. The main problem, I agree with Philippe. Of course, we can have odorous compound fixed and trapped on particulate matter. But typically, if we want to make a link with odor, all odor measurements are made without dust because we have a filtration process before. So, of course, when you are exposed on a site, you can smell it, but directly after, if you want to characterize with a level of concentration and so on, we don't know how to do that actually. Maybe we can only have data from a chemical point of view. we can trap, for example, particles on glass wool to put in a tube and desorb thermal desorption and GCMS analysis. And okay, we will see what we have, what kind of compound we have, but the relation with odor, it's still difficult in that case.
So this is the future in our exposure lab. We want to have one kind of a particle and one kind of a sensory irritant, which has also an odor. So we have studied all these single substances, and then we would like to put them together in one study. But this is a project for the future. But we have another question by Marlon. He is asking, as the exposure is often low outside concerning the chemical substances, and there are some mechanisms that are less physiological and maybe more psychological, and direct toxicological mechanisms have not been supported yet. So his question is, if the concentration of the chemical is below toxicity threshold, what indirect mechanisms do you know that can cause the symptoms? So if the odor annoyance mediates the exposure symptoms association.
On the one hand, we always deal with a complex mixture, and toxicity levels are only defined for single substances. We really do not know how different exposures interact. But yes, of course, there are also psychological mechanisms in play. I mean, odors, even when you sleep and you do not even realize it, you do not even recognize that you smell something. It can affect your sleep, your dreams, and your mood. So, I mean, there's a direct effect on the brain, even without biological, chemical mechanisms or cognition.
So there are a lot of studies on these indirect mechanisms now, and often they look if learning processes are taking place. And we have now done a study in an MRE, so we looked in the brain of our participants when they got an odor below the nose, and we compared controls with migraine patients. And the interesting thing is that they didn't really smell odor, but only water. But we told them that they would smell odor, and 80% of the participants did. And then we looked in the brain, and we find out that the migraine patients were much more affected. They felt worse after getting the odor, and they did concentration tests, and even in the easiest form of this concentration test, they were really, really bad. And migraine is an illness where an odor can make you a migraine attack. So they had some kind of fear on the possibility to smell this bad odor. So we see odor effects in the brain without odor. So if you know about these things, we have some kind of a mechanism that you can call psychologically. So this is working in the brain, yes. But we have other questions? No, no more questions until now. If I can, another question from Jose, if I can talk about more on my last slides. This was that the, I show you slides again. So these are these ones, yes. So this is coming from the original model, which was shown here. So you see that there is some resident, he has a perception, then the resident is annoyed, maybe he's also highly annoyed, so there is a difference between, yes, it's not so fine, but I can bear it, until you say, no, I don't want to live like this anymore. But a lot of other influence factors are important. Yes, if the person is working in that company, that is the odor source. So this person has no problems with the odor because he's working there. Otherwise, he would lost his workplace. Or imagine if you have also noise, if there is a loud street there, if you have train traffic also, and every day several airplanes flying above your head, a really noisy environment, and then also on top the odors. This is much more worse than the odor alone. Or for example, if you are a person who says, yes, this is how the world goes, I can't do anything about it, so I live with this and I don't complain because it doesn't matter anyhow, so this is some kind of coping, you are less annoyed. Or if you have other problems, for example, just recently your wife left you and you lost your work and you're stressed because of your life, and then on top comes the odor, intense odor, so you have more annoyance than in other situations. So these are only a lot less of all these influence factors which are important. And if you do a dose response study, you can have a big group of people in your study and you can calculate statistics and you can tell that you measure the dose response, dose annoyance relationship for a person which is mean in all these influence factors. So it has on a scale from, or it has a mean income and 2 children and so on, and then you can, for doing odor regulation on basis of those response studies, you can do or find out odor regulation limit values. But on the other side, if you are in an area where you have an actual problem, you might look at all these influence factors because one or another of these influence factors is becoming very important in this specific area. So where your limit values don't work well anymore because of these other influence factors. So this is why these factors are so important for me, and this is why I always recommend, if it is possible, to talk to the people who are living there. Is that an answer to your question? So we have another question. Yes, if anybody has recognized or not that only a few hours with very high intensity can cause the bucket to overflow. Have you seen these examples outside? Yes. So Hans, tell us about that.
Well,
yes. Just to comment my yes. Of course, intensity is a key factor, probably more than duration, and of course, all factors are in interaction. But if we make the correlation between noise and odor, typically and if we look at intensity and frequency, if you are outside an aircraft near the reactor, the noise is very intense, and you are annoyed just after a few seconds or few minutes. If you are inside the aircraft, you can stay hours in the aircraft. Of course, you have the noise, but with lower intensity, and you are not annoyed. So just a comparison. And of course, we have always limitations when we compare things. But of course, intensity, I think in the FIDO or FIDOS, intensity and offensiveness are strong weight on annoyance.
Yeah, I also agree. And in our draft guideline, we really made it clear that this odor hours only works with a continuous odor source. And if you have intermittent sources, you must also look at intensity. Because, yeah, high intensity events, even if they are rare, can be very, very annoying. I have seen several good examples of that.
So imagine this area in New Zealand. In the study, they found out that normally nobody complains, but in the seldom days when the intensity is getting high, also these people who are adapted complain because they say, oh, what happened today? Is there something other not normal? So then they also complain. So Jose asked, what factor can I use for a study of impacts on socio-economic levels due to bad odors?
Yes, of course, for Jose, yes, of course, all FIDOS factors are important, but also you must add level of education, age, so you have a lot of things to add if it's typically a social and economical point of view. The type of location, you know, if it's a flat, if it's a house, what kind of urban area, and so on.
If you own the house or if you rented it is important, or for example, if you're working or not. So if you're unemployed, you have more time at home, for example, or for example, if you have children or not. So those couples with young children complain more. Older people complain less. We found out in a rural area that those people who lived there for a long time complained more. What happened? They told us in former times this was a really nice place. You had some chickens and one horse and 2 pigs, but now you have a big barn here and here and here. So for them, it changed much. And for those people who moved there a few years ago, it was like there was. So sometimes residential time is important, but not in that way you might expect. So there are a lot of different influence factors you can assess. Another one. We asked if the person is happy about his own health status. So we did not ask directly how healthy a person is, but if the person is satisfied with their own health. So this was again another influence factor. So those people not happy with their health gave more symptoms ratings. So, other questions?
No, not a question, but I want to add, of course, all these individual factors, psychological, socioeconomic factors, health factors, are important for the individual. But for setting guideline values, I must set guideline values for the normal person or for the most vulnerable person, not for a specific person who just happens to be neighbor just now.
So at the workplace, we are now discussing, because workplace limit values are also for the normal worker, we're now discussing also to have in mind that there are some not as healthy workers. For example, those people with migraine or asthma or allergies. So all these people are working normally. So if we have to have lower limit values concerning these people are in discussion now.
I have a question of another kind. Hans, you said, well, you see there is so little investigations done on the topic of odor and annoyance, compared in comparison to other environmental issues like noise. Do you have an explanation for that?
Yeah, because of odors you don't die. It's that simple. Yes, because of noise you can die. Because of heart attack. Yeah.
No, I think it's just the exposure assessment is much more difficult for odors. Of course, as I pointed out in my presentation, also noise is not just decibel, and decibel is a poor measure, but it is very broadly in use, and everybody can measure it. Even with my mobile phone, I can measure noise.
Yeah.
The question about little research about odor and odor annoyance, I think there is a big pressure if I look at special planning, building new houses, and they don't want to have strategic thinking because there are many economic aspects and you don't want to act preventive. And that's the main topic because our governments, local governments, they see the financial investments and not the health if they look at elections.
Yeah, but
and
if
that,
they don't
that's a pity.
If they don't only look at the immediate financial benefits, they will face the problems later on.
Yes.
I hope they will realize this.
So it's the same if you look at indoor exposures and it odors indoors. So it's the same. They don't want to have a deeper look. So they do, if I don't see it, I don't have a problem. So is it interesting that I'm working in an institute for prevention? So to bring this idea of prevention in the outside world, I worked for 20 years now. Yes.
Yeah, yes, you remember, Hugo, when we wrote the standard on grid measurement. It's typically for odor exposure. Of course, a strong odor exposure can reflect an annoyance, but it's not clear when the point of changing between just strong exposure and annoyance. Mm-hmm. And so that's why it's really difficult to clearly define a study based on annoyance. But we will try to go on that way altogether, of course.
So we defined it in our studies just that simply. if you have a scale with values between 0 and 10, and everything about 7 or higher is then so-called highly annoyed. So we found these dose response curves for annoyed people and highly annoyed people. And if you have 10% highly annoyed, then behind that you have 50% annoyed people. So this was how we did find somehow a kind of a cut-off to then find out how much is too much and to associate it with the exposure, and then we use that to find some limit values for the regulation.
Yeah.
So as you said, Hans, in the noise, it's 20%, and if the measures you have to take to prevent too much noise, you take 25% highly annoyed. Yeah.
I think the problem is annoyance is also related to blood pressure increases. And Steve Wing, who was at UNC in public health, showed that people downwind from those swine facilities, many of them had elevated blood pressure. And I think what's really missing here, you asked the question, as other people did, what is missing here? And that is taking these psychological measures that you have very strongly, I mean, everybody knows this work, to take those and to relate them to blood pressure measurements. And my own experience is that these nasal cytokines measured, but I think these are the kinds of things that we have to go from this annoyance to these physiological measures. And you pointed out the salivary IgA in your own talk, and the substance P. So I mean, there are things that can be measured, and I think people are willing to do it.
Yeah. So
because in the Netherlands we have a lot of discussions going on, even with the government in concern now. So next month in November there are even talks within the government what to do on the topic of odor nuisance, because the impact of nuisance is that big and nobody knows. But if you ask the people, like Kirsten, you said, well, talk to the people, ask them how their neighborhood is, ask them how they experience the odor of pigs or whatever is there. What do they experience? And then the stories we get back now, it's also on the television and so on. Well, is very, very large impact. Yeah, the people say, well, my life is destroyed, something like that. Well, and so, well, I would say, well, if we look at it, you will see you can also die from odor nuisance.
I agree. In Switzerland, next week we have a discussion with our government, and they don't want to see this situation with odor annoyance. But I think it's a problem because they are not familiar and they don't want to see this problem. And Kirsten talked about behavioral changes. Can we use our garden? Can we open the window in heat situations, in hot seasons during the night to get cooling down? And such things are relevant to live in a good situation, to acceptable situation. And I think the behavioral changes from odor situations or physiological symptoms are very relevant to base and no longer to discuss. We can't quantify odor.
So Marlon said alpha amylase is another example that can be measured. So there are two areas where you can measure immune parameters. One is to show if you have some kind of sensory irritation, And the other would be to look if you can measure signs of stress. And what we all know is that chronic stress makes you ill in a physiological, simple, clinical, measuremental way. So I think as long if it's only annoyance, whatever this is, so you can't go to a doctor and say I'm ill, I'm annoyed. So you have to have symptoms and you have to have signs to show that you're really becoming ill or that you really don't want that anymore. So
I have to sign off.
okay.
Bye-bye.
Bye-bye.
Many thanks.
So I think we have 18 o'clock now. Maybe we have, if there are no other questions anymore, a little farewell round so everybody can say at the end a short statement. Who wants to start? Yeah.
I want to thank you all. It was really an interesting conference. I learned a lot. I think we agree on many points. Of course, we have different approaches and looked at from different aspects. But one thing is certainly true. Well, more research is needed. Is always true. But yes, odors and annoying odors are a problem, and they are very much underappreciated, and there is need to act from the scientific side, but also in the regulatory arena. Thank you.
So Hugo or Jean-Michel, who you want to say something?
Well, thanks to Olores to give us the platform. And well, when will be the next meeting? I think to discuss in this way with each other is well very helpful. I hope for everyone.
Thank you.
Okay, of course, thanks to Olores for organizing this meeting. Thanks to all of you, yes, to exchange. As Hans said, yes, we globally all agree, but we can see that with different point of view, there is still a lot of job to do, of course, to understand how it works. And typically, as a relation with toxicity, of course, we have some elements, but we need more data, more experiments, more feedback, and so on, and of course more exchanges. So, like Hugo, can we schedule the next meeting?
Yeah.
Okay, thank you.
Yeah. Thank you very much, everybody who stayed as long with us. So I would like to point out that we have the new developments in the way that the stakeholders, or as I call them, residents, are involved more and more. And I think this is a good idea also to implement this into regulational approaches. So I think we are on a good way, and I look happy into the future. And yes, I would like to see you all again and discuss with you, because I'm, as a researcher, I only learn from your questions. So thank you very much and have a nice evening then. Until next time.
Thank you very much.
Bye.
Thank you to all the speakers for sure, and to all the attendees. And yeah, for sure, we are waiting for the next webinar like this. So thank you all. Have a lovely evening. Bye bye.